peonies burst in December. I promised you I'd set them to verse, so I'd always remember that the meteorite is the source of the light, and the meteor's just what we see. And the meteoroid is a stone that's devoid of the fire that propelled it to thee. And the meteorite's just what causes the light, and the meteor's how it's perceived. And the meteoroid's a bone thrown from the void that lies quiet, an offering to thee.
Okay, so the meteorite is what causes the light, and the meteor is how it's perceived. And the meteoroid is a bone thrown from the void that lies quiet and offering to thee. That was Joanna Newsom. She's beautiful. This whole album is beautiful. I mean, the entire album. And I'm not going to do a thought experiment about this song because the entire song is a thought experiment. And I'm going to begin with an analogy that's going to bring us to write this pair of equations which I have boxed down here. And this pair of equations is going to be deceptively simple, but don't worry, you won't be deceived. We're going to make it more complicated later. Now, beginning with the analogy, suppose you are a droplet of water flowing downstream in a river, and you look at the riverbank, and you're not engaged in circular flow, you're engaged in laminar flow. So you look at the riverbank and you say, that's the fastest speed there is, the speed of the riverbank. The analogy, obviously, is the speed of the riverbank with the speed of electromagnetic waves in vacuum. And let's suppose you look at the other droplets of water around you, and you notice they aren't moving. And that's the analogy for our wrong-headed coordinate system, which would place the which would assume that mass isn't moving, and we want a kinetic theory of gravity eventually. So, well, so let's not overreach too much, but the droplets of water around you are not moving. I mean, you could see that because they're around you and they are in laminar flow just like you. But the riverbank is moving very quickly, and that's this highest speed in this universe, in this river universe. So then you decide that you want to reach the bank speed, and you notice that there's a lot of circular flow in this region. So this region has circular flow, and this region, which has circular flow, is traveling really fast relative to you. And this region with the circular flow is, it's at the same speed as the riverbank, which is the fastest speed in this universe. So what you want to do is you want to somehow drive yourself towards the stationary anchor, and then you're going to start spinning along with the other circular flows in this region. And then when you eventually hit that stationary anchor, you're going to be at the speed of the riverbank, the fastest speed on Earth, on the space-time. So, if you indulge in this analogy, we can eventually transform it, we can eventually formalize it with the luminocentric principle, which is something I talked about on other videos. And I'm going to introduce the postulate of directional indeterminacy that says we are not at rest, but we don't know in which direction we are moving with respect to vacuum. And then I'm going to go to the corollary of special relativity, which is really a postulate of special relativity, but here I've I've demoted special relativity to a corollary. Come on. No, this is really a postulate of special relativity. If we measure our speed with respect to electromagnetic waves in vacuum, the result will equal this constant, which we call c, the speed of light, which we say is approximately 3 times 10 to the 8th meters per second. Now there's the coordinate postulate, which is that which has the same speed in every direction is identically stationary. And so the speed is 0. Just think about it. If you have the same relative speed to all objects, then you cannot be moving with respect to any of them. So your speed is identically 0. And then we have what I call the meta theory. Because the final velocity is 0 when accelerating, in quotes, because the final velocity is 0 when accelerating towards the speed of light, we are really decelerating towards the speed of light. From an initial velocity v0, which is our velocity, to a final velocity v1, which is the velocity we wish to arrive at, it follows that the final velocity equals 0. The difference between our velocity and the final velocity is 0 minus c, and that equals negative c. And so the norm, this symbol here is the absolute value in terms of vectors. And remember, we're in a one-dimensional world here. It only turns into 2 dimensions because a velocity has a distance and a time. So we're doing a 2-dimensional world disguised in 1 dimension of distance. And in this 1 dimension of distance, we still can have a velocity, because we can have a velocity pointing, we can have a distance pointing one way, which we call, say, a positive velocity, and then the distance pointing the other way, which we would then call a negative velocity. So we have an absolute value operation, which we call the norm, and we say that the norm of the difference between these 2 velocities is equal to c, but the actual difference between these 2 velocities is equal to negative c. Now, this is deceptively simple, like I said before, so let's make it a little bit more complicated. And we were looking at this formula before, but I'll reintroduce it. This is very simply a formula that tells a story. And the story is the story of how to calculate mass. Now, the true story of how to calculate mass says that mass sets up a gravitational field, and because mass sets up a gravitational field, we calculate mass by comparing it to another mass. So that's how we calculate mass in practice. We say that mass sets one single mass is enough to set up gravity, and then that's enough to compare it with other masses. Of course, if we're comparing with other masses, we're assuming that there's already many masses in the universe. You see? So we're really jumping to conclusions without really being sure that one single mass in the universe can really set up a gravitational field. But let's not get sidetracked. Let's go back to the very simple story of this formula, which is you apply a force to the mass for a duration, a time t. That mass, which you wish to calculate, you do not know, was traveling at an initial velocity v naught, which you do know, which you can measure. And because you applied this force for time t, the mass went from velocity v0 to a velocity v1. And when you took this difference and you divided by the time that you applied the force, and this force has to be a known force, as long as this force is a known force, then you can calculate the mass. It's just plugging in numbers. But we have to do something with this formula because Newtonian physics would have realized that there's something wrong with it, which is this. If you have no force, then the numerator becomes a zero. The change in velocity also becomes a zero. So the numerator and the denominator is a zero. We have an indeterminate form. So just give me a second.